Let's try some harder problems. So let's start right here. This is still a classic solve for x problem. So I'm going to get rid of this root 3 first by subtracting. So I have 2 sine x equals negative root 3. Then I can divide by 2. So I get sine x equals negative root 3 over 2. Hey, that looks like the problems we had in the first video now. So this means what angles will give us a y value, because that's what sine is, of negative root 3 over 2. So I go up here, find negative root 3 over 2 as a y value. So there's one there, and there's one there. Both of those have y values of negative root 3 over 2. So both of those angles are our answers, 4 pi thirds and 5 pi thirds. Now, you will notice I have been putting all the answers so far in radians, not degrees. That is on purpose, because if you read the instructions right here, there's your interval from 0 to 2 pi. If it says that, that means your answers should be in radians. If it said from 0 to 360, then your answer would be in degrees. Okay, we're going to skip the tangent for now because it's the hardest. Let's come to this one. This problem is kind of like this problem. And hopefully you remember from junior high when we were solving problems like this, that if you have variables on both sides of the equations, your very first step should always be to get both variables on the same side. So like subtract x to both sides. So now I only have x's on one side of the equation instead of 2. So I'm going to do the same thing here. Minus cos of x minus cos. So I get root 2 equals negative cos minus cos, just like this. Negative x minus x is going to be negative 2 cos. Divide by negative 2. So I have cosine of x equals negative root 2 over 2. And remember from the last lesson that we learned that negative root 2 over 2 is the same thing as negative 1 over root 2. Those are the same thing. So we are looking for an angle that has an x value of negative root 2 over 2 or negative 1 over 2. Same thing. So I come up here, I need x values of negative root 2 over 2. So it looks like right there and right there. So I look at the angle, 3 pi fourths and 5 pi fourths. So those are going to be my answer. Okay, now let's get to the tangent one. Tangent's definitely the hardest because remember, tangent is y over x. So what I would like to do is go through and kind of make a tangent unit circle really quickly. Now, just like we learned last time that all the lines of the same color have the same points, it's going to be the same thing with tangent. So if I find the tangent value for this one, it's going to be the same tangent value for all those blue lines. So I really just need to find the tangent value for these 3, and then it's the same ones all the way across. So we're going to go through and do that really quickly. We're going to make a little tangent chart. So let's start with the blue ones. That's not how you spell blue. Let's try that again. There we go. Okay. Tangent is y over x. So I look at the blue lines. The y value is root 3 over 2. The x value is 1 over 2. Now I need to do leave, flip, change. Leave the numerator, flip the denominator, change that division fraction to multiplying. My 2 on top and bottom cancel, so I'm just left with root 3 over 1, which is just root 3. So that means the tangent value for all these blue lines is going to be root 3. Now, just like we did with the unit circle, the number's the same, but the signs will be different. So if we look at this, a positive y divided by a positive x is going to give us a positive answer. But if I look over here at this one, a positive y divided by a negative x is going to give me a negative answer. Let's try down here. A negative y divided by a negative x. Well, two negatives make a positive, so this answer is still going to be positive. And then over here I have a negative y divided by a positive x. So this answer is also going to be negative. And just like the other ones, those signs will stay the same for the whole corner. So all our tangent values in this corner and this corner will be positive, while all our tangent values in this corner and this corner will be negative. So now that we've settled all that, let's do the pink line. So y over x, I have root 2 over 2 divided by root 2 over 2. You can also use your 1 over root 2 over 1 over root 2. You should end up at the same answer. Leave, flip, change, leave my numerator, flip my denominator, so that's a 2. Change the division fraction to multiplying. And I have a root 2 on top and bottom that cancels. And I have a 2 on top and bottom that cancels. Now this is a very common mistake. If everything cancels when you're multiplying, it's not 0, it's 1. And we can kind of see that back here. I have the same thing on top and bottom. This is like 5 divided by 5. If you have the same thing on top and bottom, that simplifies to 1. So the tangent values for all the pink should all be 1. And then we add our signs. This one's positive, this one's negative, this one's positive, this one's negative. Okay, finally, let's do the yellow. Y over x, the y value is 1/2. The x value is root 3 over 2. Leave, flip, change. Leave the numerator. Flip the denominator. Change the division fraction to multiplying. My 2's on top and bottom cancel, and I'm left with 1 on top, root 3 on bottom. So the tangent values for all the yellow ones are 1 over root 3. Now, there are 4 other tangent values I would like to do while we're on this subject, and it's at our coordinates. So this one, remember y over x, so it would be 0 divided by 1. 0 divided by 1 is going to be 0. Same thing with over here. 0 divided by negative 1 is also going to be 0. So those are the tangent values for 0 and pi. Now let's look up here, y divided by x, so 1 divided by 0, that's undefined or does not exist. So same with down here, negative 1 divided by 0, still undefined. So the tangent values for pi halves and 3 by halves are undefined. Okay, now that we have all our tangent values done, let's try and do this problem. I'm going to add root 3 to both sides. We're just solving for x right now. 3 tan x equals root 3. Divide by 3 on both sides, so I get tan x equals root 3 over 3. Now, let's actually reference this one over here. Remember, we've said all chapter long, root 2 over 2 is the same thing as 1 over root 2. So, root 3 over 3 is going to be the same thing as 1 over root 3. So we are looking for a tangent value of 1 over root 3. So let's go to our tangent unit circle now. 1 over root 3. Oops, I forgot to add my negatives to this one, didn't I? That's my bad. There we go. Okay, tangent value of 1 over root 3, a positive. So there's a positive 1 over root 3, and there's a positive 1 over root 3. So our angles are pi 6 and 7 pi 6. So that is going to be our answers. Okay, in the next video, we're going to do these slightly harder problems and then talk about what we're going to do when our answer is not a point on the unit circle.